Thanks.
Give me about 4 seconds.
Uh, that is just fine.
Are you actually on screen, or is it just going to be my presentation for the whole thing?
I mean, they can
All
see me
right.
as long as Zoom. Can you see me?
Yes.
Okay, good
Kind
enough for
of.
me. Do you want to see me? Hey,
Yeah.
Jackie. This presentation looks cool. You guys don't even know. I mean, it might be bad. Is that good? Yeah. I'm just it's showmanship, right? Not me, man. I feel pretty loud. I do it all the time, man. Come on. Yeah, thank you. Spencer, let me know for when we're ready.
We're live. You're being live streamed now.
Okay, we're good. All right.
Good.
Well, it's November 10th, 2025, and welcome to Jeff's dinner party pregame slash general meeting of the Los Angeles Astronomical Society. Who do we have that are new members? We're going back up there. Oh, is it? Oh my God, this is the best thing ever. Is it? All right, let's have it, guys. What do we got?
Hi everyone, my name is Xavi. I'm from Barcelona. I found it through Nick, who found it through Jeff. General interest, I guess. I'm not in the field, but yeah, I'm always mesmerized. No problem.
Thank you very much.
Hi everyone, I'm Adam, also a friend of Jeff, and I'm just here to try it out. Hi everybody.
Hi, I'm Ricardo. I'm also a friend of Jeff's. I studied abroad in Chile in college, so the Chile connection was of interest to me, so I'm interested to hear about it.
Well, the presentation may be good. Suspense.
We're getting a lot of static coming through on the mic.
Yeah, I'm coming around. Whoa. All right, make yourself known, friend.
All right, good evening, everybody. My name's Sean. I'm an astronautical engineering student at USC, and I work with the Space Force, so that's my connection.
Also fight on. All right, anyone else? Hands? Feet? All right. You got one more? That was okay. That was like a T-Rex hand. I couldn't see it.
I wasn't sure. Anyways, I'm Alana, and I'm friends with Laura May. She's amazing. And I have a general interest in astronomy and the stars.
And that's all that's required. Anyone else? Nope. Okay. All right. That's awesome. Oh yeah, is there any? Oh, I can't see Zoom, but are there any members on Zoom? Any new members? Going once? Okay, good enough for me. All right, so
on Zoom,
what?
there's a fan noise going on.
What's that?
There's a drone fan noise going on Zoom. Really difficult to hear.
All right.
It's a lot like
Yeah, I know. Is somebody not muted on Zoom?
No, just say hi. I just
Could do that. All right. Well, the
Oh,
agenda for
okay,
today.
there
is
we
we're
go.
going-
Okay, good job.
Yep.
No
Zoom
noise.
fixed itself. This feels so intrusive. Yeah, Spencer, go ahead and mute everybody while we're going here.
I did.
Okay, awesome. Okay, so we're going to jump to our speaker who's going to speak. Then we'll have a little Q&A at the end of it. Then I'm going to announce the announcements. I'm going to proclaim my affection for the member that I'm giving the good heavens acknowledgement to. Then we're going to give away some door prizes. And I'm going to tell you what your future may hold within the club with upcoming events. And so with no further ado, adieu. Sorry, there was an opportunity there and I took it. Yeah.
I appreciate that. Thank you kindly. All right, we finally got things to work, potentially, maybe. All right, so hello, everyone. My name is Lorme Abron. There we go. I work in this wonderful institution, Griffith Observatory, Los Angeles. I also work on asteroids and comets like this one. No, it's not aliens, it's 3I Atlas. So it's been an exciting time to work on the interstellar comet. And I've also been lucky to do a lot of observations up on Mauna Kea, on observatories like Keck and Gemini and IRTF. But I come from this wonderful city of lights, which is the land of light pollution, so not the best place for astronomy. And before I start the talk, I just want to give a quick shout out to the Grand Canyon. I was just their astronomer in residence. And they are amazing people. This is run by the Grand Canyon Conservancy, and as you can imagine, we were all affected by the shutdown. And the main reason I tell you this is that this, for example, is the view right on the south rim. You can tell there's a light right next to me, so I tried to capture the sky as it is if you just walk outside from your hotel. So I would say it's probably the darkest night sky, or the closest mortal one that we have. So I highly recommend that you make your way to the Grand Canyon South Rim. It's about 8 hours drive from here, and really, really incredible sky, which is why they say that half the park is after dark. So if you paid attention to the news this summer, you might have seen this. No, not all the horrible violence and things like that in the world, but just in that little corner, that little sliver of hope, the first celestial images from a revolutionary telescope. Did anyone see this in the news? Yeah, a couple of you. So we indeed had the very first images that were unveiled from one of the telescopes and observatories I'm going to talk about tonight. Obviously, let's take a closer look at it since we are an astronomical society here. So this is the Lagoon Nebula. It's one of the first images they released, and it is a star-forming region in the Sagittarius constellation, also known as M8. So it's a little similar to the Orion Nebula. And it was shot by this amazing observatory that doesn't really look like an observatory. This building on the left you see here is the Vera Rubin telescope that just had its first light this past June. And it's named after an astronomer who proved the existence of dark matter by looking at galaxies. Her name was Vera Rubin, and she was actually commemorated a couple months ago on a US quarter that you can still buy online. Fun fact, she's actually not the first astronomer and not the first female astronomer on a coin in the US. Sally Ride, also an astronomer who had a coin earlier this year. Now, this telescope actually sits close to another major observatory. So this is the Gemini South, which began operations in the year 2000. And it's so-called Gemini because it has a little twin in Hawaii. And I say little, they're both the exact same size. In fact, they have an 8.1 meter telescope that you can see right there. it's a little nerve-wracking, let me tell you, when you're staring right into one of these amazing mirrors. And that is actually the mirror that captured that image of Three Eye Atlas that I showed you earlier. And now both of these are located on the same ridge on the Cerro Pachon. This is in north central Chile, and this is approximately about 60 miles by road from the support town of La Serena, where the Rubin Observatory base facility is located. And a little closer to home, the LSST camera, or so the camera from the Rubin Observatory, was actually built in California by the Department of Energy's SLAC. So the DOE's Office of Science co-funds the observatory, which is a joint initiative with the National Science Foundation. I had no idea that the Department of Energy did all these things, but they actually fund quite a few laboratories and things like that. And its specific contribution was funding for the camera and development work. And so they built it right in North California at the National Accelerator Lab, which is operated by Stanford University. And anyone remember Clippy? I saw someone dressed as Clippy for Halloween. Bad memories, nightmares, perhaps. So this is actually linked to the Vera Rubin Observatory, believe it or not, because Charles Simoni, who is the head of development for Microsoft Word and for Excel, he actually funded the beautiful Simoni Survey Telescope. So this is the actual image. You're seeing the actual telescope, the camera, and it'll operate on an automated cadence. So that means it's just doing automatic scans of the sky, basically. And it's going to survey the entire night sky every couple of nights, and then it repeats it again and again. And for those of us here who have telescopes, it is a custom-built out azimuth that you might have recognized. But more interestingly, it features a very unique three-mirror design. So this creates an exceptionally wide field of view, and the primary that you can see is actually 8.4 meters, and it weighs about 36,000 pounds. So pretty hefty. And it is the largest digital camera ever constructed for astronomy, so it's roughly the size of a small car, and it weighs over 3 tons, close to 7,000 pounds. So when I was lucky to be there this summer, it was still, so the observatory is still technically in construction. So even though it had its first light, there's still a lot that they're working on. And this is a special camera that is 3,200 megapixels to map the entire night sky every single 3 days. So it's going to create the first 3D virtual map of the visible cosmos while recording changes in stars with events like supernovas. And the focal plane, again, for the nerds amongst us, is about 189 charge-coupled device, so CCDs, that are arranged on 21 rafts, and it has a combined 3.2 gigapixels. So I thought I'd give you a little comparison. The latest iPhone, which is not on there, is about 48 megapixels, which means this is more than, so that's about 1% of the camera on the Vera Rubin Observatory. But of course, megapixels are not the only factor that determine an image's resolution. You also have sensor size, you have lens quality, software processing, and all sorts of other things. And right here, this is the field of view, which is about 3.5 degrees or 9.6 degrees square. So this entire field of view of the camera is basically about 40 times the size of the full moon. So a pretty amazing tool. And here's what we can expect. So I know this is an illustration, but it's to give you an idea of what the previous images of the sky that we had from surveys would have looked like and how deep we're going to be able to go with the images from the Rubin. And right here, this is one of the first images that they released, as well with that Lagoon Nebula. So this is the Virgo cluster, and this is a mosaic that's 3.2 gigapixels, and it's made from about 1,100 individual exposures that were taken over 7 hours, right? So in this image, there's about 10 million galaxies, and many of these have never been studied before. We've never been able to image them in this level of resolution. And this covers an area that's about 70 times larger than the full moon. So again, this is a composite mosaic. And according to my math, that should be about 3.5 degrees or about 210 arc minutes. And the full resolution image, which you can download, all these images, you can find them online, use them as your screensavers. And so they're about 10,000 by 5,600 pixels. So I give you all these numbers because this is important to the point that we are getting an enormous amount of data. So this is a zoomed in image. So that little, right in that top left kind of corner, this is the zoomed in, and you can still see the incredible resolution on this. I urge you again to go online, zoom in on these images, and look for yourself, see the amount of detail that we're going to be done. And this is really just the start of the 10-year survey that's going to be done. So originally, the telescope or the observatory was called the LSST, which stood for Large Synoptic Survey Telescope, but it now stands for the Legacy Survey and Space and Time that it is performing. So we rename things in astronomy. And it also found about 2,000 asteroids in just a few nights of observation. So we think that it might also make it easier to find new interstellar objects. For example, we might get about one per year. For the moment, we had one in 2017, Oumuamua. We had in 2019 Comet Borisov, and of course this year when we discovered Comet Atlas. So do bear in mind, though, that we do know the majority of very, very large telescopes, and so the asteroids that it found are really, really small little asteroids. And we've got one more link to California with the Vera Rubin, not just the camera, because right in our backyard is what served as the prototype for the Rubin. Any of you ever been down to Palomar Observatory? Yeah, a couple of you. Yes, I'm sure several of you, and probably several of you online as well. So this is the ZTF instrument. It is located right at Palomar Observatory, and it stands for Zwicky Transient Facility. Fun fact, Zwicky was also kind of the father of dark matter. He theorized its existence, so now we have an observatory named after Vera Rubin that proved its existence, and after Zwicky, of course, that theorized it. So the way this works is that there are up to about 1 million alerts per night for transient objects, right? Again, 1 million individual alerts that denote something that changed in the sky. So this might be an asteroid, this might be a kilonova. I took part this summer in a workshop where we were taught how to basically code and program for specific detections, right? Because we can't possibly have enough people and enough time to comb through 1 million alerts every single night and assess whether something is, for example, an artifact or something like that, or if it's a legitimate, maybe a supernova that we've just discovered, right? So in fact, this is the moment when I will pitch to you and for any of our young viewers to get into data science, because in astronomy, this is a major problem. We now have so much data that we can't actually comb through all of it, which is why, again, we use programming to look through at least a lot of it, but you can actually access this data and look through it if you'd like. So ZTF is actually going to work with the Vera Rubin Observatory because it has a higher cadence. So it combs through the sky a little faster. The resolution is not as good, but it will serve a very important purpose. And to give you an idea, so there's going to be about 20 terabytes of data per night created on the Vera Rubin. So an enormous amount, and it's going to produce a 15 petabyte catalog database that we will all be able to use. And in order to look through all of this data and to process it, there are dedicated computer facilities in a couple places. There's one in the south of France, in Lyon, and there's one in Tucson and California. So all of that is going to be processing all of the data from Vera Rubin in real time and issuing worldwide public alerts within 60 seconds of detected changes in the sky. So when we say this is going to revolutionize astronomy, it is not a joke. And if you're wondering what it looks like to be an astronomer engineer, I think my parents or my mother certainly asked me a couple times, do you just like look through telescopes all day? No, sadly. But this is the control room, for example, of the Vera Rubin. So lots of science happening there, and it looks a little similar to what we do on Mauna Kea. So usually, in fact, there's also a telescope operator when you are pointing the telescope at a specific thing, and then you get to also give details of where you want to look and things like that. And Rubin, by the way, is very particular in the world of astronomy because it was designed and it was created with education in mind. So all of the Vera Rubin programs, they all have explanations online. There's educational resources that have been placed online. There's really a ton you can access. If you do any form of science communication or outreach, I urge you to go on there. Someone this week actually printed out for me the coloring book, the Vera Rubin coloring book, which I strongly recommend. band. And of course, there will also be, so even if you don't want to comb through millions of alerts, for example, there will be several citizen science projects that will be done in partnership with Galaxy Zoo that will allow people, the public, to comb through data in a way that's a little more accessible, a little more intuitive. I don't know if, is everyone here familiar with Galaxy Zoo? One or two of you. So the Galaxy Zoo project started with classifying galaxies. So it was essentially a huge amount of pictures, and people could just look through them, and they were given pretty specific instructions, and they could classify galaxies. And then that was done for a whole bunch of other things, objects like brown dwarfs. There's even some nature projects on there, but it's actually pretty fun. And if you discover something, you actually get quoted on the papers. So pretty cool initiative. And this is not, of course, we've talked a lot now about the Vera Rubin, and it's been in the news a lot, but this is not the only telescope in Chile. There are quite a few of them. In fact, there's about 40 international, university, public, and private observatories that operate on Chilean soil. And there's currently, on top of these, about 115 professional and amateur observatories. So you might be wondering, how did this happen? A lot of people are not necessarily aware that all of this was happening in Chile. And this is a fairly old story. So in spite of the other more controversial involvements of the US and Chile, this is the result of nearly 2 centuries of collaboration between Chile and the United States. So in 1849, the US Navy sent a lieutenant to contribute measurements to an international project to calculate Earth's orbit. So they went to Chile, and he built a small observatory, which you can see here on this very old engraving from 1872. He trained a bunch of staff there, and that ended up becoming the National Astronomical Observatory in Chile. And this brings us back again to California. There's lots and lots of tie-in between Chile and California. So about a half a century later, some representatives from University of California's Lick Observatory, it's located about east of San Jose, and this one was built in the 1880s. So they came and they built a second observatory in Chile. So they had already understood a little bit of what makes Chile really, really special for astronomy. And this is the Victor Blanco telescope. It was built in the 70s, a little bit later, and it was named after a Puerto Rican astronomer. And he actually advocated to the government of Salvador Allende to be able to build it. And for 20 years, this was the largest optical telescope in the southern hemisphere. And it is a twin of the 4-meter Mile telescope on Kitt Peak in Arizona. And by the way, the images and all the data it has collected have yielded more Nobel-winning discoveries than any other telescope, including for the 2011 win on the expansion of the universe. So the Rubin, the Blanco, Gemini South, they're all operated by Noir Lab. And I just wanted to give you a little bit of eye candy. So it has a very famous camera. It's called the Dark Energy camera, and it captured this incredible image last year. This is a cometary globule. It's found in the Gum Nebula in the constellations of Vela and Puppis. Sadly, not accessible to us here, but if you ever go down to Chile. So unfortunately, the US supported military coup in 1973 that helped install Auguste Pinochet, paused a lot of the building of new observatories for 20 years. But we were able, again, to resume operations. Now, the Blanco that I just showed you is the flagship of CTIO. So that's the Cerro Tololo Inter-American Observatory. And it sits next to what's called the Mushroom Farm. So it is a host of loads of these little observatories that you can see here. And many of them are quite small. They have pretty small mirrors. And there's about 40 telescopes right there. This is, by the way, I hope this gives some people here in this club ideas. You know, one day LAAS could have a robotic observatory there. Lots and lots of private institutions that are observing from there. And this includes my favorite telescope in all of Chile, probably also the smallest one there. And some people will recognize this gong, familiar to any of the solar observers in the club. We have David Pinsky, of course, here. And this is one of the gong telescopes. So again, another connection to California. The other one of the other ones, so there's, let me go back. So there's 6 of them, and there's an engineering site. One of them is no longer functional, the one on Mauna Lea. But we have one not just a couple hours north of here at Big Bear Lake. And the network actually is celebrating 30 years of operation this year. So it provides constant monitoring of the sun, solar flares, prominences, and all sorts of activities. So pretty essential operations. Now, eventually, when the dictatorship ended, foreign astronomers returned to Chile, and they began renegotiating bilateral agreements to build the next generation of large telescopes. So fast forward to the 1990s, when Europe funded the building of this amazing telescope you might recognize. I had a poster of it on my wall growing up. This is the Very Large Telescope, also known as the VLT. It is in Paranal, and it is operated by the Europeans, the European Southern Observatory. And it's taken some pretty remarkable images that have also won 3 Nobel Prizes and given us incredible images like these of these planet-forming regions. So these are, you're looking at protoplanetary disks. So these are very warm disks of gas and dust that are forming new planets, right? So these are baby solar systems, a little bit like we would have looked like some billion years ago. And it is also one of the most productive facilities for astronomy, second only to the Hubble Space Telescope in terms of the number of scientific papers that it's produced. And this, you might recognize, it doesn't look like an observatory to most people, but it is another major, major observatory. It's ALMA, which stands for the Atacama. That's where it's located, the Atacama Desert, large millimeter array, and it started operating in 2013. So it's only been operating for about 12 or so years, and it's a radio observatory. So that means they can observe 24/7, including in daylight. In fact, it's even created some observations of the sun. So we can observe the sun in all sorts of wavelengths, which is very important to understand more about it. And it has about 66 dishes of varying sizes that have been funded by different groups. And all of these dishes, by the way, can be up to about 16 kilometers apart for the extended array. So all these dishes get moved around in order to create different types of telescopes where we can observe different things, right? If you ever visit New Mexico, you can also go there to see a very, very famous telescope that looks just like it, that is called the Very Large Array, where Contact was filmed, famous science fiction film. And because it sits very, very high up, it's at 16,000 feet, so that's more than halfway up Mount Everest, you can only go up there with oxygen. There's also regulations for how long you're allowed to stay up there. You have to do a whole bunch of tests to get on there, even just to get on the site. Everyone has to do, gosh, I don't know what they're called in English, when you do an alcohol test. Breathalyzer, that's the one. So they make you do a breathalyzer when you arrive on site. They don't want anyone drunk and doing astronomy. It's not the way. So you might think that this is the highest observatory in the world, right? 16,000 feet. So I do want to clarify also that most of these places have remote observation rooms, right? So they're not actually sending the astronomers up there to observe. We were really lucky. I got to go up there. Most people never go up there. Even some of the astronomers who are observing with ALMA, they stay down below at some of the observation, some of the remote control rooms. So the main people who are working up there are the engineers who are moving, who are helping move everything around. And it is not the highest observatory in the world. That honor actually belongs to an observatory that you can see from this place, and that is the University of Tokyo Atacama Observatory. It's also called TAO. So we could see it from there on a mountain, even higher up, and it's at 18,500 feet high on Mount Chajnantor in the Atacama Desert. So it's a 6.5 meter optical infrared telescope, and it is now the highest in the world. It just began operations, or I think they're about to begin operations. There used to be a smaller one called Mini Tau. And being so high is really, really useful for astronomy because it means less moisture in the air. I nearly put in the pictures of my fingers that when you are staying, as we did at ALMA, your fingers in just a couple of hours will start cracking and bleeding. So it's one of the funnest things. It's the same thing on Mauna Kea, but yeah, we're all lizards in astronomy. So TAO can actually observe almost the entire range of near-infrared wavelengths, including mid-infrared. So there's no other Earth-bound telescopes that can actually do this. And these observatories are really able to stretch the limits of astronomical observation from Earth. And they're taking higher resolution shots of space thanks to, again, their large aperture and larger than some of their space-based counterparts. So pretty impressive. And this telescope's mostly going to be used to learn about the birth of galaxies and the origin of planets. So that's a lot of what's going on there also is protoplanetary disks and things like that. Which brings me to this very, very famous image. You might have seen it before. This is really one of the most famous images from ALMA, the ALMA telescope. And it is a protoplanetary disk surrounding a star called HL Tau. So what you're seeing is the start of a solar system, much like our own. And if you really consider the amazing resolution that we're able to get this with, and again, this is from the radio telescope, and this was quoted, by the way, in over 1,000 scientific papers in less than a decade. And to give you a comparison to our own solar system, so on the right here, you have our solar system, and that outer line here, that outer little circle, that is the orbit of Neptune, so it is displayed to scale with this forming protoplanetary disk. And you might be even more familiar with these images of the supermassive black holes. So here we have the supermassive black hole at the center of the galaxy M87 and the one at the center of our own Milky Way galaxy. And there's about 4,000 published papers that are using ALMA's data. So again, in just about a decade, pretty incredible. So ALMA was a big part in these images that use several telescopes on Earth. They combine their signals. Essentially, this was an interferometry project in order to create this incredible shot of a supermassive black hole. Now, by 2030, 70% of the world's astronomical infrastructure is going to be located in Chile. Pretty amazing, right? More than half of everything on the planet down in Chile within a patch of desert that's going to be about the size of Oregon. So you might be thinking, why specifically are we putting everything in Chile? And there's quite a few reasons for this. And the first is that it has a very, very unique geography. You know this probably because you've probably seen images of the country. It's a very long country, although not the longest country on Earth. That's apparently Brazil, I found out. But you can kind of note already the masses of clouds, snow. So this is the general location of most of these observatories. And you can kind of see, so this is the coastal range. So in light blue on that image on the right, again, the coastal range. And then in the middle, we've got this hyper-arid core in yellow. And then the Andes Mountains and their foothills are in green. So it's a really, really special geography. And those mountains are especially good at blocking moisture from either side. So here's a better cut showing you. And of course, keep in mind those observatories are sitting right in the middle here on the Andes Mountain. And this really creates the 4 magic ingredients that we need for astronomy research. So we need high altitude, we need extremely low humidity, we need very stable weather, so lots and lots of clear nights, and we need enormous stretches of uninhabited land, thanks to which we can have very minimal light pollution. And so that is why Chile now is becoming the top place in the world for astronomy. It's actually interesting that it is also an analog for Mars. So maybe someday we'll have some observatories on Mars. And I'm just going to run you through some of the 2 of the major projects that are being built now that are even larger than the ones already there. So this is the GMT. And it has 7 primary mirrors. Each of them are about 27 feet in diameter. And they have about they're using 17 metric tons of specialized Japanese glass. So it's one of those colossal observatories that's currently under construction in the Atacama Desert, and it's going to have 10 times the resolving power of the Hubble Space Telescope. Now keep in mind, we do put things, I'm sure many of you know this, but we put things in space because it gets us rid of the atmosphere, right? But this is kind of the closest we can get to a lack of atmosphere. It's very, very high up in the Chilean desert. And of course, we also have the European Extremely Large Telescope. Believe it or not, the Overwhelmingly Large Telescope was also an option for a previous telescope. We do love our big astronomy names. And so this is currently being built as well. So it's being built very close to the VLT, the Very Large Telescope. And it's got 128 feet main mirror. It is as tall, more or less, as the Statue of Liberty. And it's going to be able to directly image and study the atmospheres of potentially habitable exoplanets, so planets around other stars. Now, there's also a very important human ingredient in this entire mix of why Chile has become such a powerhouse. And that is thanks to two specific astronomers, so Chilean astronomers. When all these observatories started being built, there was a new condition that was brought in that said 10% of observation time had to be reserved for Chilean astronomers. So just to give you a kind of comparison, in Mauna Kea in Hawaii, 50% of the observation time on the telescopes that are built up there are for University of Hawaii. So it's a little bit of a similar system that they had. Now the problem is that the 10% rule was actually not being applied for a very long time until two astronomers, so these two right here, so Monica Rubio and Maria Teresa Ruiz, convinced the government to actually apply these rules. And since then, all of the number of professional Chilean astronomers has actually become 10 times greater. So there's about 300 Chilean astronomers now and about 800 undergrads and postgrad students that are studying astronomy or related fields. Now that might not seem like a large amount of people, but if you consider that there are 13,000, roughly we think there's about 13,000 astronomers in the world, that actually makes up a big chunk of it for a country that's not enormous like Chile. And we'll have to see how many people they manage to actually get into astronomy, but I suspect that with the Vera Rubin coming online, they will have even more astronomers. Now, astronomy is also a huge part of Chilean culture, right? But this is not a new thing. This is, by the way, a mural that was made in San Pedro de Atacama, a town not far from the Alma, and it is absolutely phenomenal. There's even a picture or a drawing of the black hole on there. But there is an enormous amount of astronomy tourism. So keep in mind, the world over, we are losing access to the night sky. And so it's pretty fascinating that they've been able to combine having all of these research observatories with having tourist business there and having a lot of astronomy tourism that takes people out to see the stars and do all sorts of things like that. I was floored by how it was absolutely everywhere in Chile. And as I was saying, the night sky is disappearing. So it's pretty remarkable that they are able to do this, and I hope that it helps them conserve parts of the night sky. So we think that the skies right now around the world are getting about 10% brighter on average each year. I didn't originally believe that number when I was told that, and I did find the study. And the study is pretty reliable, and it was done with a lot of data from citizen scientists. So I urge you, as an aside, to get involved with dark sky preservation, because I certainly wish that we could have that in Los Angeles. Who here, show of hands, has seen something like this before? Okay, couple of people, mostly the people who work here are astronomers. So this is one exposure. For the astrophotographers out there, I shot this just outside of the CTIO observatory, and it is one 25 second exposure, right? That's how good the night sky is. And we think that most of the world's population right now will never see the Milky Way. And in North America, by the way, that figure is about 80% of people who've never seen the Milky Way, and it's close to 100% in the United States. So pretty dramatic. And one of the cool things about being in the Southern Hemisphere, as anyone who's traveled there can tell you in a dark sky, is that you actually get to see more galaxies than we do in the Northern Hemisphere. So in the Northern Hemisphere, we have access to the Milky Way if you're in a dark sky, and if you're in a really dark sky, you have access to the Andromeda galaxy. Some people say you can also see the Triangulum galaxy. I have never met someone who's seen it with the naked eye. Anyone atop here seen the Triangulum? No. So I'd say we have about 2 galaxies, our own and Andromeda, but if you go to the Southern Hemisphere, you will be blown away by the Magellanic Clouds. So these are satellite galaxies to ours. They sit pretty close to each other, and if you're looking at the night sky, they're about, I'd say, if you hold your fist up in front of you, depending on the size of your hand, they're about that size in the sky. I originally thought it was an actual cloud, and I suppose that's why they were named this way. So one of the major tourist sites in Chile is actually in the sky, which is pretty amazing. And Chilean cosmovision, so that is their vision of the cosmos, their associated stories and myths, this is fairly old, right? So there are traces of Chilean cosmovision that go back to about 1000 BCE. And this term, Wenu Mapu, is one of their cosmovision terms, and it denotes the land above. Wenu is up, Mapu is land, and this is how they conceptualize the celestial world. There are differences across Chile, of course. There's lots of different native tribes. But one of the most beautiful stories that I learned there is a cosmovision that doesn't just use the stars and constellations as we do, but it also uses what are called dark constellations. So I'll go back to that image I showed you. So right here you can see all of these little dark images, all those dark lanes that are going through the Milky Way. Now those are not empty parts of the Milky Way, those are parts of the Milky Way that are dust lanes, that are actually hiding the other stars that we have behind them. And so they have constellations that correspond to all of them. If you look at them for a while, you'll start seeing those things in the Milky Way. They have a llama, they have a baby llama, there is a serpent, a bird, and these were very, very important to local cosmovision and stories and mythologies. The dark llama comes up frequently as having jumped into the Milky Way. So a really, really beautiful culture of astronomy. And believe it or not, even though all of these research facilities are the biggest in the world, the most important, where the most research comes out of, they are being threatened. So this is a project right now that is starting to be built just outside of the Very Large Telescope, the VLT, and there is a mining project that threatens all of these, or some of these observatories that are located there. So something to keep in mind for all of our research observatories. So the concept of astronomy for diplomacy and for human development is very, very important. And astronomy is not just about telescopes or data, right? Many of us who are members of the Los Angeles Astronomical Society are not astronomers. And this is about really wonder and perspective. And I think that's really one of the big lessons to learn from Chile and Chilean astronomy, is that they've really managed to inject this in everything that they're doing, whether it's the research projects, the education that comes from it, all of the culture surrounding it, tourism, diplomacy. And I think that when we do star parties or engagement, we're speaking to people who maybe don't have an interest in astronomy, they've never had an interest, and this could really be the only time they come into close contact with astronomy in their life, but we really have an opportunity to enrich their lives in some way, which is something I really thought about a lot in Chile, and how we can do better, all of us, to basically improve astronomy, improve our engagement with the public, and hopefully that leads to wonderful projects and more astronomy, more research, and more funding. And I want to thank the ACEAP Astronomy Ambassadors Program, which was actually funded by the NSF. I think my year, this year was the last year that it was actually funded by the National Science Foundation. So I would not have been able to go without this funding. And it's being cut, I believe, by the current administration, without getting political. But all of these projects are also, so all of these telescopes, all these observatories are funded by Noir Lab and AUI, and you can actually apply to this program. So if you are involved in astronomy, either you're a professional or you do a lot of engagement and outreach, they will actually potentially send you to Chile to be able to learn about these telescopes, visit them, and learn about some of the research that's being conducted there. So I want to thank you so much for being here tonight, for listening to me talk about Chile. I could have talked for another hour, but here we are, and you can follow me on Instagram or come to Griffith for All Space Considered, or watch it on YouTube. And of course, this lecture will also be on YouTube. Thank you so much.
Thank you very much. Do we have questions? It's got to be one. Very thorough. I sort of had one, I guess. For the Vera Rubin one, I mean, it's catching the whole night sky as a giant survey. Is that an issue that the observatory is so far south? Can it get everything from down there?
I was actually going to touch upon that. So much as I'm very excited about 70% of the world's, research facilities being in Chile, we can't just have everything in Chile. That's the problem. As you said, They can only access the southern hemisphere. There's a little bit of overlap with ZTF that I mentioned that's at Palomar, but we need to find some sort of way to have many other facilities in the northern hemisphere. If you're in the world of astronomy, you know that right now this is a very, very contentious topic because of some of the things. So, the way they did this in Chile was great in the sense that I didn't fully mention it, but there's a lot of partnerships with local communities and the Chilean government, and there's just a lot of communication amongst everyone, it seems. And this was not done so well in Hawaii. Unfortunately, as a person who works on Mauna Kea, sometimes it's a very tense situation. There are people who don't want the astronomy to be there anymore. And Mauna Kea is still the best sky in the world. Chile is pretty much up there as well. But again, we need north and south. So what will happen to astronomy in the northern hemisphere? I don't know. There are talks about relocating a project that was supposed to be up in Hawaii in Spain. I doubt that will happen because just the conditions there are not as good in Canarias. But yeah, this is all amazing, and now the southern hemisphere is just like covered and incredible, and we're going to make all of our discoveries there. But occasionally there are objects, for example, that we want to see in the northern hemisphere. And yeah, we will see what happens with the next generation telescopes. Yeah.
Awesome. Anyone else here? Out on Zoom. I think I saw. Oh, we got one. Okay, it's Jeff. Nice.
I was wondering how the new generation of telescopes compares to James Webb.
I eat 4 meals on these days.
Yeah, that's a really good question. So the way James Webb works is that you do a proposal, and and then you get to observe your object if your proposal is accepted, right? And so there are committees that get together and they approve what we're going to look at in the sky. Sometimes a lot of people pitch for the same thing, and then that gets decided. The way Rubin works is a little bit different because it's doing a sky survey, so it's surveying the entire sky. And so, the resolution on Rubin is honestly shocking. It's incredible. And many of those other observatories are going to be used for support operations. So if, something needs following up, one of the other observatories can take it on, for example. So they're kind of different types of telescopes. So again, we have the survey-based telescopes, and then we have things that are more proposal-based. So they're going to look at one specific object because one astronomer made a proposal to look at this. And so they're a little bit difficult to compare because they do different things. They also observe in different wavelengths. So in fact, for a while, James Webb was touted as, it's the replacement of Hubble, but it's not, because it's actually observing a different wavelength, right? It has better infrared capacity than the Hubble, for example. And the other thing is that, as I mentioned, James Webb and Hubble, for example, they're outside of the atmosphere. So there's a bunch of stuff on Earth that we cannot access. X-ray, for example, the Chandra, for example, is the most famous one, up above the atmosphere, and it can observe the universe in X-ray. So it's detecting all of the things we really cannot get from down on Earth. So all of these things are complementary. We all, we need all of them, which is why you should buy us more telescopes and fund every telescope.
We can band them together. 4,000 6-inch refractors with a rubber band. Yeah. Spencer, I think I saw little questions flicking up on Zoom. Is that true?
Yeah, actually, I had one. So, what are the prospects that something can be done to curb that light pollution from the INA project?
From that mining project?
Yeah. Mm-hmm.
I know they're in discussions with them. What's funny is that when I was at Grand Canyon, they were in discussion with the mining project there because they are also a protected sky, and I think they were trying to come to some sort of compromise or, explaining the importance of the night sky and how much work has gone into to have it be preserved there. So I'm not aware of specific I mean, I know they're doing negotiations right now with that mining. From what I was seeing, it was actually kind of really concerning. That this might actually destroy the VLT. So I don't know where they are at. I'm hopeful that, if there's enough outcry from the public in Chile or the community worldwide or things like that, the mining operations may, I don't know, mitigate. I mean, mitigating light pollution is not that hard. At the Grand Canyon, they retrofitted about 5,200 light fixtures. And, that's just really putting caps on fixtures, making sure the light bulbs aren't going further down, and making sure sometimes also just the number of kelvins, so the color of those bulbs you have to have within a certain range. And yeah, so I'm curious. This is really brand new. It's not, the project itself is not new, but the negotiations and this being kind of in the public ether for this mining project next to the VLT is relatively new. And I'm curious as to what's going to happen, because honestly, I don't know that it's a clear cut at this point, but it would be really, really bad. Again, hopefully astronomy is big enough in Chile that they have some leverage, but we're still just astronomy people. For us, it's like, oh my gosh, these projects are the most important thing in the world. But for people outside of astronomy, they're just like, who cares? Right?
Half of them are worried about the firmament.
Several of us wrote letters to the Chilean ambassador.
Booth Hartley's signed in.
We've lost your audio.
What'd you say? They couldn't hear that. I was just saying, this is an issue that is worldwide. The issue of light pollution, like I said, goes up by about 10%. I've been going to Iceland for 15 years, and I can tell you I have seen the increase in light pollution where there are parts of Iceland you really can't see the northern lights anymore, whereas it is smack in the middle of, it's one of the best spots in the world to see them. So, everyone is concerned by this. We recently had the park assessments for the parks in LA, and I think we were one or two people saying, hey, please try to be more aware of the lighting in the parks and try to protect the sky a little bit. And really, this is not a partisan issue. So you can contact your representatives at any moment, go to a town hall meeting and say, hey, what are we doing about light pollution? And it's an easier problem to solve than climate change. So much easier to solve. So I feel like this is really something that if you're kind of lazy, just get involved, because it's easier to solve.
Try to get that easy W, right? All right, I saw Justin's question whiz by, so I'll go ahead and cherry pick it. He was wondering if you had any tales to tell about difficulties on building in such treacherous places like those large buildings. Yeah.
Yeah, but there are people who died, and I don't want to put a cloud over incredible astronomy achievements. Some telescopes. So I had heard of someone who died a little bit before I was there and saw one of these observatories, and I want to be clear that it was not one of the U.S. run observatories. It is not an observatory that I went to. But yeah, there's accidents, and these observatories are an enormous thing to maintain. If you look at a thing like ALMA, for example, all of those 66 radio dishes get moved. They have these enormous tractors. There's a reason why they send us up there with oxygen. At one point, I removed my mask to take a picture, and they're like, no, put your mask back on. And there was someone in my group, actually, who I think his oxygen was not flowing, and he was saying stuff, and we were like, what? And then I think someone was like, here, put up his oxygen. So yeah, a lot of people who are up there, I think we're pretty lucky as astronomers that most of the time, I go up on Mauna Kea and it is perilous and it is physically taxing. But the people who work up on the Alma Plateau, for example, who are engineers and who are, some of them, they're construction people and technicians, man, it is brutal up there. They have these huge gallon-sized jugs of sunscreen as well, because when you're up there, you will absolutely burn. I think I was talking to someone who was mentioning the rate of skin cancer, for example, in Chile and in places, that are up in the mountains. So, yeah, it's very dangerous locations, and this is part of why also now we're lucky we have remote observatories. But a lot of the people who are engineers and doing technical work, they still have to be up there. So, yeah, I'm not going to go into specific anecdotes because I don't want to ruin. But I will say though that Chile has the highest standards of safety I've seen of anywhere. I had a whole talk on hypobaria when I was there, and they really put a lot of work into safety. They have a lot of unions. So I was really impressed by that. And yeah, the observatory where I knew something had happened was not part of the Noir Lab and all of those NSF-funded facilities.
Eric had a question about, he caught the whole thing about, wait, they drag the observatories with tractors? Question. And then I'm going to actually jump off the tail of that. And how are the internal combustion engines doing up there with the lack of oxygen? Or did you see more like electric vehicles, or is there anything like that was noticeable?
And, I don't even have a car. I've never had a car in my life, so I'm like the worst person to talk about this stuff to. But yeah, I didn't include photos, and maybe I should have next time. They have these enormous, they have a specific name, I forget, the crawlers, I guess. They're similar to the ones that move, those huge rockets in Florida. So they have these kind of equivalent crawlers that move all the antennas, and we got to see one on the inside in one of the hangars, and it's the wheels are bigger than I am, but yeah, I don't know about the combustion. I know that because also they're in the desert. All the fuel, all the water, etc., all of this is brought in by truck, by the way. There's all the engineers who live on these facilities. Everything's brought in by truck. And so it is an enormous amount of work to get all these things working and including to, get fuel for all of these tractors to move all that equipment around. It's incredible. But yeah, we'll have to look up. I'm curious now about your question.
Right. All right, what else do we have up there, Spencer?
That was it, I think. Let's see. Somebody mentioned ICs do okay because they're high compression. So internal combustion engines. So yeah.
Or maybe diesel, especially.
Oh, they might be diesel actually.
All right, cool. We're back in house. Nice.
Thank you for this lecture. I might have misheard you, but I think at some point in your lecture you mentioned a public alert system that would go out in 60 seconds. I guess my question is two-part. Public alert for what, and how does the public alert go out, especially given sovereignty and things like that? Is it here? If it was here, would it be through NWS or?
It's expected.
Yeah, so the alerts are for the Vera Rubin Observatory for the transients. So there's lots of different types of transients. There can be supernova, there can be kilonova, interstellar objects, things like that. So I'm aware of the functioning for ZTF, which is that, all of this data goes through brokers. So you can kind of investigate this if you want. It's a little bit convoluted. I learned about this summer on a workshop that I was on. But, it's not like it goes in the news and we suddenly, flood the news with a million alerts about things. Yeah, it usually, at least the way that ZTF works, it goes through a bunch of different data brokers, and then you can access it, and you'll have to create an account and things like that. But all of this data usually is public, so you can access it. Again, it depends on the observatories. It depends on sometimes there's delays for release of certain things, but I'm pretty sure all the data from Rubin, I'm trying to think, because it's going to be released as a catalog at some point, but the alerts themselves should be accessible through data brokers and things like that, I expect. And if you go on their website, it will generally show you the pipeline of how that happens. But if you are familiar a little bit with programming, for example, and things like that, usually that makes it a little easier to comb through kind of the root source of it. And yeah, people go in there sometimes and they find things. And yeah, there's going to be a lot of alerts. In fact, they went back. I should have shown that image, but they went back and they were lucky they caught 3i Atlas before it was actually discovered by a separate network in Chile called Atlas. And so you can go back. They went back through their data and they had found it. Or they found it in their data. So yeah, all of these things are things that usually, even for ZTF, I mean, look it up now. Look up tutorials on it if you're interested in that, and go through the data brokers and the pipelines to try and have access to it. But yeah, over probably about 10 million transient alerts per night. That's most of them will, again, some of them will be other things, artifacts, etc. But there's a bunch of stuff that, yeah, we need help to comb through all that. We have a data hoarding problem in science, in astronomy, or hoarders.
And you give the engineers a minute and they take a mile. Oh, it's all right. I don't mind. This is my life now. It's good.
Okay, so back to what we were talking about before. You said people actually live up there, like in 16,000 feet. Are the inside of the buildings where they're living, are they pressurized like an airplane cabin? Or like what is going on up there? Or were they born to live up there? I mean, you know what I mean?
Like the Tibetans, right?
So I should clarify that the 16,000 feet is where those antennas are. The accommodations are lower. I forget at what elevation. I think they were almost, I'm trying to remember because, for example, when we work on Mauna Kea, we stay in a residence called Hale Pahaku, and it is still hot. Like you're walking to breakfast and you're like, and so it's the residence for Alma is a little bit higher up. So that's all I was mentioning. We stayed up there for a couple nights, and yeah, my fingers were cracking and things like that. But yeah, people live up there, and it's not pressurized, but it's just and yeah. So there are a lot of native people who are somewhat more accustomed to it, and you do become accustomed to altitude after a while, a little bit more. Living at the Grand Canyon, even though it's not a very high altitude, I could feel the difference when I came back here. But yeah, that's part of engineering and things like that. But when you're up at the summit, there are, where I was with the oxygen mask, there are limits of how long you're allowed to stay up there. And every single person going up there gets health tested. I nearly couldn't go up because I was so excited to go up that like they were, I don't know, measuring my pulse, and it was like, "Argh!" And they're like, okay, you need to calm down or you can't. And we had some people in our group who actually couldn't go up. So there's a variety of tests and health requirements to work up there. So yeah, it's pretty brutal, and it's pretty amazing for the engineers and all those people. And yeah, they live for a certain amount of time, in the desert. I will say they have these amazing sports facilities at Alma, and they organize these like inter-observatory Olympiads. And I saw all these trophies, and you must be super fit if you live up there. So it was pretty impressive. But someone in my group, they went and ran 5K on a treadmill the day before, and then they're like, wow, I feel so unwell. Yes. So yeah, that's the reality of living up there and everywhere has humidifiers, by the way. It's the same on Mauna Kea, but as soon as you get into your room or something, you're like, you put that on because the air is so dry. Yeah.
I can imagine like the observatory softball league up there. Very competitive. Yeah, exactly. But they all do. I wonder if like certain astronomers get recruited for their prowess athletically to get that vaunted title. When I come back down there, you have to come up with a name for what that trophy would be.
Yeah, hi. A pretty amazing, fascinating talk. Yeah. And I was actually more interested because I'm planning to go to Chile next year in July just to do some astronomy and observe the skies. And I'll be staying about 3-4 nights in Atacama near San Pedro. So the question is, do you have any tips that maybe I should, so that I don't miss anything, or any useful tips you have?
I'll go slowly to build drama. I wish I could just slide down this thing. Just whoosh. No, this is a point. It's pointy.
Yes, I was actually going to make a pitch, or it was a thinly veiled pitch when I was showing the Magellanic Clouds, to encourage everyone to go down there and to mention that there are visits for some of these observatories. Now, I doubt that you'll be able to go up to the ALMA summit. I actually had a request from someone at Griffith Observatory connected to our management who wanted to go up there recently and couldn't make it happen. So again, because it is fairly, health-wise difficult and things like that. But you can visit a lot of the facilities there. I'd say contact them now, get in touch and say, hey, you know, what do I need to do? Do I need reservations or things like that? But I know that there are fixed days. Let's see, I think CTIO had like a fixed day every week. I think Vera Rubin you can't visit yet because they're still in construction. But I'm sure you know, go on a new moon, obviously. You know, you want to maximize how much of the Milky Way you're going to get to see. And there are also, so you said you're going near Alma? Yeah. I'm trying to think, because the other ones, there's actually observatory, there's a really cool observatory called Alpha Aldea that is right below Cerro Pachon, where Rubin and Gemini are, and they're amazing, and they have like a little homemade planetarium and everything. They're super cool. But the places there, I'm trying to think. A night tour, I don't, maybe. I think, you know what, check their websites, and if not, just get in touch with them, because I know they're doing tons of engagement and outreach, and it's just that there's specific days. So, you know, Alma and places like that, I'm pretty sure. I know that Alma also is building a visitor center, for example. I don't think that's going to be ready right away. But some of them for sure give tours, whether it's night tours, I don't know. But honestly, if you want to do some astrophotography, anywhere basically around there is just amazing with very low light pollution. But yeah, for specific observatories, or if you drop me an email, I can try to also see which ones have specific visits. But yeah, and I can ask some of the people I worked with. But yeah, just, you know, get in touch with any of the observatories there and ask them what kind of requirements they have and how you can visit. And I know they almost all have an open day here and there. Yes, yeah, I didn't go to Las Campanas and La Silla and things like that. La Silla, yep. But I think you can. Sorry, that was terrifying. Yeah, Las Campanas, La Silla. You know, I didn't even go to all the observatories. There's so many of them there. And yeah, almost all of them. Again, they just have very specific requirements. There was someone who died, an astronomer who died, I want to say a decade ago, at La Silla maybe, or Las Campanas. He wandered off. And yeah, so there's a lot of just very specific requirements just for everyone's safety. Because yeah, these are dangerous conditions, and it's really dark at night there. So, you know, you fall off a cliff. They don't want you to do that.
All right, let's see. What's the way to go through it? Let's see. I'm going to go up top. No, it isn't. It seems that way, but it isn't.
So for those with a data science background who want to get involved with some of the data work, how would they go about doing that? I work in a analytics department, and I kind of want to put the word out to our data scientists to get involved.
Yeah, that's a really great question. And there's tons of people who come from data science and not astronomy. I was really surprised this ZTF and Rubin workshop that I did this summer. Loads of the people there, they were explaining some really basic astronomy stuff. And I was like, what? And it was because tons of the people came from data science and engineering and stuff. And in a way, you guys are more useful than us astronomers in that. So I would actually look up the ZTF workshop, see if there's any access to any of the materials, because I felt that they explained really well kind of the pipeline of all the data. And, the Rubin will have specific things. They may have another workshop. Gosh, there was a workshop. Actually, AAS. I don't know if you guys are familiar with AAS. This is the big astronomical conference that we have. It's twice a year, but the really big one is in January. And they actually had a workshop. So this year it starts on, I think, the 5th of January, 2026. And before the conferences, so it's fairly steep to go. But before the conferences, they actually have workshops. And the workshops were pretty cheap. It was $100 or something to attend. And they had a workshop on Rubin data. So I saw this on the website a couple of days ago because I might go to that. So you can look up, there are workshops that will teach you, because again, it's, if you know a little bit about data science and programming, it's fairly straightforward. You have to kind of know the process of where the data is going. And with Rubin specifically, I'm sure they already have a full pipeline created. But yeah, I would check that workshop on the AAS website and see if that, and if you can attend. Yeah, it's in Phoenix. So it's going to be early January. And that's going to be pretty cool. Otherwise, look up online for ZTF workshop. Sorry, ZTF. Or some of these similar, those pipelines should be fairly easy to find. And yeah, you can get involved if you're not an astronomer usually. And I'm sure they'll be at some point recruiting people.
I see you, Con. Coming.
Well, thanks for the presentation. Very good. Very fantastic. So, actually, I got two questions. So the first one is, so you just mentioned you work in the Grand Canyon, right? So I've been here for several times. So I also go to the Death Valley. So Death Valley is another good place for astrophotographing, right? So it's also a border one place. It's much closer. So I've been there several times. From the light pollution maps, so it said it's border one, but so I've been there several times for meteor shower and Milky Way shooting. So I would say the humidity here is very dry, and but the only thing is the elevation is very low. So my first question is how matter is the elevation play important role in the astronomical things, So yeah, that's my first question. So the second one is, you just mentioned that in the past few decades, the atmospheres keep brighter. So I guess that includes the Chile, right? So when I do the astrophotographing, I always attach the light pollution filters in front of my cameras. So in astronomical science fields, so can you attach some filters to the observatory? So yeah, that's my second question.
I still have announcements to do. So
So regarding Death Valley, yes, Death Valley is closer. I don't know, man. Sometimes the skies I've seen there are really light polluted by Vegas. It depends which part of Death Valley you're in. Some parts are a little better. I, like you, went to see the Geminids some years ago there. And it's true, I got some really good Milky Way shots. I don't know, the Grand Canyon seemed way better to me. And that just may be because I was there for a long time or something like that. But it's true. I actually usually recommend Death Valley over Joshua Tree. Joshua Tree's cool, but I feel like Death Valley's way better in terms of closer, and Grand Canyon is a next one. Regarding light pollution filters, I actually am not sure that we do this because, with the size of these telescopes, and sometimes if you're looking in infrared, for example, and things like that, I don't know that we can really play with these things. I mean, I'm sure there's some level of mitigation. And of course, there's mitigation for atmospheric turbulence. So, lasers and adaptive optics and all of that is used to basically correct for atmospheric, turbulence. But I don't know if there's any solution for light pollution. I mean, I think it's just you're cooked. If what I heard was that if this mining project actually opens next to the VLT's cooked. That may not be the case, and they may find solutions, but I don't know that we really have ways to mitigate, because when you're looking at things with such deep, small resolution, we work on asteroids. I remember we got the last images, I think ground-based, of YR4, the one that it might hit Earth, but it actually maybe is going to hit the moon. And, that thing was 2 pixels on our screen. And so, I think that by that point, especially when you're doing things like this, light pollution is a slightly different issue, and I don't know that we can really do much about it. It obviously, it'll affect your seeing and things like that, but yeah, remind me what your first question was? Oh, yeah. Elevation is super important because it just gives us better access to some of the infrared wavelengths. There's less humidity. It contributes in many, many ways to, we just have to have all these observatories at very high elevation, Mauna Kea, Chile, all those mountains. And again, they help guard us somewhat against light pollution from nearby, human villages and towns and things like that. But part of it is also just humidity is really bad, for example, for infrared. And so you really don't want to have any humidity. So the higher up you are, slightly, you're going to have, in most places, not ever, but you're going to have decreased humidity. And that's actually part of why, even though people talk about putting the 30-meter telescope on in Canarias in Spain, it's really humid there. There's a lot more cloudy nights. I just think that a lot of the research opportunities, for example, for asteroids and things like that, or things that depend on infrared, would be lost. They just don't really have the best conditions. But I don't know. I'm not one of the engineers planning this, so yeah.
All right. Do we have anything else on Zoom?
Don't really see anything.
Okay, we're gonna do one more because we got to get to announcements pretty soon. So the question that Rafa asked was how these observatories deal with all the satellite light pollution.
Yeah, good question to end on. I was actually working our Edge of Space today at Griffith Observatory, so I was taking calls, and this guy called, and he was like, I just saw this thing in the sky. There's all these trails, and I was like, yeah, that sounds like Starlink. And he was like, but how can we do astronomy or something? And, this is a major problem now. I don't know if any of you tried to shoot Comet Lemon. I tried when I was at Grand Canyon, and it was in what my friend calls the Elon Musk's garbage patch. And every year in the past, I want to say decade, this is horrible. This hurts me. Keith just showed me this picture of Comet Lemon in between 3 million satellite trails. And the American Astronomical Society has put out reports on this for the past decade, I want to say, alerting people, because also there's a lack of legal framework around low Earth orbits and around who owns them, for example. So one company, as is happening now with Starlink, they can put all of their satellites there and, essentially occupy all of these low Earth orbits, and then that's it, So yes, the atmosphere is vast and there's a lot of orbits, but it's a huge problem. We've alerted, I think, again, the American Astronomical Society, many groups have alerted government and communities and about this issue, and no one really seems to be doing anything about it. And so, again, and I'm sorry to get political, but I do urge you to talk to your representatives. Science is political, unfortunately, now. And, talk to your representatives and say you're concerned about this. And at some point, when it becomes bad enough, maybe someone will do something about it, but we are at a major risk of a variety of things. In fact, there was a near collision, I think, a couple days ago and I can't remember if this was low Earth orbit, but in 2020, there was a near collision. I think they passed 12 meters of each other between IRAS, so this is an old NASA observatory, and an Air Force observatory, and they passed really close to each other. And in fact, one of those observatories had a giant boom that they thought, even if they miss each other, the boom's gonna kind of crash into the other satellite. And yeah, so it's, the skies, the potential that we can't put anything more up there if we end up with a cascade of debris at some point. This is a real issue that, I'm glad we can end on that because it's a problem for astronomy. Most of them are really visible on the low horizon. So mini telescopes, they don't go that low. Palomar, in fact, I was told an amusing story about someone who dipped the telescope on Palomar low enough that the mirror nearly fell out. I don't know if it's an urban legend or not, but so we don't necessarily observe super, super low, but sometimes we do, and it's a major issue for lots and lots of reasons. So thank you for your consideration for that. And thank you for having me.
For those of you on Zoom, I just posted the link for the door prizes, so go ahead and register.
All right, we have, President Emeritus gets certain.
Oh boy, I just wanted to add that there's a paper came out just a couple of months ago that the new generation of Starlink satellites are generating about 30 times as much radio noise as the first generation, and they're generating it into the pass bands that are protected for radio astronomy. So it's not just the optical astronomers, it's the radio astronomers are also now having problems with background noise from the satellite.
Traffic.
Not to mention things like reflect, and I'll leave one last comment to that, reflect orbital, even though we don't think the math is mathing on that. There is a startup right now that wants to put up a bunch of mirrors to reflect sunlight down on Earth.
For pay.
Yes.
Because you want that.
Yeah, we don't want that.
Somebody wants that.
Is all, the U.S. military probably wants
Yeah.
that.
Yeah. I will say, that was a really good presentation. Okay, so announcements. Probably the most, it's not in any particular order, just how I wrote it down. Elections are coming up. So if you wish to be a board member and you've been in the club for a year, reach out to secretary@laas.org and you will get a form. Then you have to write a bio that we all get to read about you. And if it's good enough, then your one Wednesday a month belongs to us. How's that? And if you've been on the board for a year, then you should know better. But you could aim for the prize. You can take my spot. You could do it. You can be an officer. So we're going to be voting, I think, pretty soon. I think at somewhere after Thanksgiving, if I'm not mistaken. So even if you don't want to be doing this, but you want to control our lives, that's fine. Good for you.
Ballots will go out shortly before Thanksgiving, and they'll be due December 7th.
There it is. So vote. If you want the club to function in a particular way, and like-minded folks to you, vote them in. The board does a lot. It's not just skull and crossbones kind of thing. We actually are. The meetings almost always run over because we care a lot, and we try to do the most with the opportunity we're afforded by having a club our size and in such a, we'll call it a fertile breeding ground for astronomical endeavor, where we are. And I personally am really proud of this board and the club at large, what we've done this year. And let's do it again. So vote. And then, since I'm being soppy, donate. Also, we're coming close to the year's end. So Laura May can have an observatory. No, just kidding. No, it's for the club. We are a 501c3, and so your donations are tax write-offs. So if you have more money than you wished you had, then I don't relate. But donate. Okay, beyond that, we have the banquet coming up on January 25th. I think that is, I'm pretty sure, yeah, it's the single largest gathering we have every year of LAAS members. It's really cool seeing everybody in the daylight wearing the same clothes. It's not just cold weather people. It's a riot. Yeah, there's people that you've only talked to on Groups.io. You get to see what they look like. That alone is worth it. So look for the form to set up to sign up for that. It's a lot of fun. It's really great. So I hope to see you there. And next up would be a plea, a light plea, a request, gentle, from Ed, who runs the club Instagram. If you have something cool that you want to put up on Instagram, you can just DM him on Instagram, and he will consider it if it's cool by his standards. But he does a really great job with it, and it's always nice to have club stuff up there, and it's really cool to share. We have a huge, for an astronomy club, our 30,000 followers is a lot. So this is a way for you potentially even to get new followers yourself, because that's quite a cool megaphone. So that's a thing. And then also write for the bulletin. I talk about this all the time. Michael has been doing a really, really good job. If you haven't noticed, this year the bulletin has looked sleek and efficient, and is quite an appealing publication, and you can be part of it. You don't have to know a lot about Chilean observatories or or radio astronomy. You can just have a funny story to tell about your experience with the club or the like. But write for the bulletin. It's great. All right, and at this point, I'll get to my good heavens portion of the program, where I like to pull out a little acknowledgement for a member that I think decides a little light shine on their efforts. And for this month, I would like to mention our patron saint at SCAS. His name is Al Alisea, and there's only one way in Hades that you will ever see this guy, is if you're up there. He's done so much. I mean, it's wild. I mean, he's weatherproofed some of our observatories up there just on his own, just goes and gets the material and just does it. He's up there water sealing pads. The C-14 rig in the Carson Brucker Observatory, its functionality is pretty much due to him specifically. Through all of those inspections that we had to deal with over the last couple of years with the county, he was there to host them. He makes sure the robotic observatory in California is operating properly. He's kind of the chaperone of that for all of us. When we did the electrical up there, he didn't even ask for help. He literally took all of the stuff out of all of the buildings so they could redo the electrical and put it all right back in there, and it was pretty insane. And there's been just so many times where it's like, we need to just call Al, and he just does it. So and if you've ever been up there, he's the nicest guy, and he'll help you with your own telescope. He's a really good astrophotographer, and he gives advice for that. So I could go on about this guy. He's not really with the board of directors, and he doesn't show up down here that much, so he doesn't get enough attention, and that's a shame, because he is a really great guy and he does a lot for us. So thank you very much, Al. And with that, let's give some stuff away. We do that last. It's all writ. It's my digital scroll.
Just giving away 2, right?
Yeah.
Is there anybody, first of all, is there anybody who did not get a ticket? Everybody has one? Okay, here we go. The first number is. Gift shops. Gift shops for both, right? Okay, the first number is 8335. Last numbers is 433. Got a winner up there. All right. Okay. Yeah. It's a free trip to Chile, right? 8335. That was actually quite funny. 8335. Last number is 442. Who's got it? Evan, did you win? It's about, hey, the man runs everything tonight. Yes, he is. He's a member, yes. And everybody, by the way, thank you so much for all you doing for us as well. He's the one that's putting everything together here for us, as well as Laura May.
All right, Spencer.
Okay, hang on
Way to
one
go,
second.
Governor.
Just a second. Let me pull them. Okay, I just closed out the list, so here we go.
I'll do it. I'll send it to him.
All right, 1 second here.
Well, no, not really, because the people online were getting a $25 thing and the laser, so we're just kind of evening it out.
Okay, so the first winner is
Somebody wants a
Jose.
laser, gets-
So first one is Jose Aguilar.
All right. Thank you.
Okay, and we're doing two, right?
Yes, sir.
Okay. Second one is Sergio Gonzalez.
Oh, wow. Nice.
All right. Now is where I get to tell you what's coming up. If you liked this, we're doing it again next month on. All right, we're doing it. We're doing it again on December 8th in this very place at 8 o'clock. I hope to see you there. If you like this place but you don't like this, we'll be doing a star party here on the 22nd. That one will be great. We'll be christening the new lawn, which is looking. It's a different grass. Kind of has like boy band hair vibe right now, you know. Yeah, it's pretty lush, I gotta say. Okay, it's like, you know, it's kinda
One
nice.
one
I
thing about
I think it's
the,
better than us. Yeah.
Oh, Keith, one thing about the meeting next month, it's the show and tell.
Oh, okay.
So I'll be sending out a form for people who would like to present their favorite image, the newest shiny toy that they got, to talk about that, or a trip or something. So look for an email with the form to describe what you're going to do a show and tell on.
That's always a fun one. Okay, so after that we have Silver Lake Outreach this Thursday, 11/13. Our next big one with music and such is going to be on the 20th. Santa Monica is going to be popping off on the 15th. We have a lot of school outreaches. Dave's done a fantastic job getting us in the saddle with that, so get ready. We have one in Altadena on the 14th. We have a daytime one in Pasadena on the 16th. We have another one on the 18th in Monrovia. We have another one on the 19th in Azusa, and another one on the 21st in Santa Fe Springs. So this is really the essence of outreach, and I would dare to say that we've probably crafted an astronomer or two in that. So look for that on the Groups.io or on the calendars. They're all listed. I recommend you attend, and I'll be going to probably at least 3 of those. If you want to come to family night, too bad. We're not doing it until next spring. But if you still want to go up there with Dark Sky Night, our next one is going to be on November 22nd, which is the same day as the Griffith thing. So I'm vastly torn on what to do because I love them both so dearly. But whichever one I don't go to it on my behalf. We have the last Mount Wilson Star Party of the year on November 14th. Definitely going to that one. I feel like there's a certain zeal. 15th. Oh, crap. That's right. 15th. Yes. Is it the 15th? I guess it is the 15th. Yeah. Yeah. So watch out for weather. Hopefully we won't. But right. So, but the 14th on the Friday is likely going to be washed out. That's the last 60-inch night of the year. So, via con Dios, if you paid for that ticket. Not looking good though. All right, but what is looking good is the board of directors. We look great. You should check it out on the Zoom. If you, this is it. This is, yes, the handsomest folks. If you want to sit in on it and see what it's like, the next one's going to be on December 3rd. It's a Zoom-only thing. It's a lot of jurisprudence and talking about nothing that has anything to do with astronomy, maybe tangentially, but it is important. And then the next Lockwood Committee meeting is to be determined because it's actually going to be a big one. So whenever it does happen, it's actually good to attend this one if you care about SCAS as much as Al does. We're going to have our civil engineer and land use consultants sitting on that one, and we're going to be talking a lot about what we're going to do more specifically with our old property and our new property. Excellent. Laura May told me to tell you that a notice will go out about the next centennial committee meeting to help plan our centennial, which is nearly upon us. And that is the news. Anyone else have anything to say? Nothing. Astronomy rules. Don't shoot satellites. Be kind to your neighbors. And thank you very much.
Hey, Jack, you there?
Hey, hang on, Dave. Let me stop the recording.